Okay, here we are, week 3, and this week we have a test. So this is the last new thing that we are going to do before we have our test. And what you're going to notice about this last thing is that it's going to feel like exactly what we did with the last lesson, where it was multiplying rational expressions, because dividing rational expressions is very similar. Okay, so this warm-up, if you want to try this on your own, you could stop the video right now and you could try to see if you can answer these on your own, and then turn it back on and you can see what it is that I'm doing here. All right, here we go. I'm going to do it. So if you want to do it on your own, you better pause it now. All right, how many quarters are in $5? Well, there's 4 quarters per dollar, right? And there's $5, so that means there are 20 quarters. Okay, and then it says, well, how many dimes are in $5? Well, there's 10 dimes in $1, so that means there are 50 dimes. You might be thinking, well, what the heck does this have to do with multiplying or dividing rational expressions? Well, there's another way to think about this. A quarter is 1/4, right, of $1. And so what we're going to do is we're going to take $5 and we're going to divide it by 1/4 of $1. Let me rewrite this. I'm going to write it a little differently than using a fraction. So we're going to take 5 and divide it by 1/4. Well, if we think about what we did in the previous one, we took $5 and we multiplied it by 4 because there are 4 quarters in every dollar. Well, if we think about what we see right here, we're dividing by 1/4, but if we simply just take this fraction and we flip it over and we change the sign to multiplication, we're going to get the answer that we got in the first box, because 5 times 4, remember this is 5 over 1, and we just multiply across, and the ones are insignificant here because they don't change anything. So 5 times 4 is 20. Okay, so we know we have the right answer in that first box because we just showed using division that the number of quarters in a $5 is 20. Let's try it with dimes and see if we can do the same thing. All right, a dime, if you think about a dime, what fraction of $1 is a dime? Well, a dime, since there are 10 dimes in $1, that means it's 1/10. So we're going to divide 5 by 1/10. But dividing 5 by 1/10 is the same as multiplying by 10 over 1. So we're going to do the same thing. So we end up with 50. Okay, so what did we just do? Well, we divided rational expressions. And the way that we divide rational expressions is kind of explained down below. And I'll explain what we did. When we took this fraction and we flipped it over, and when we took this fraction and we flipped it over, we did what's called taking the reciprocal of it. And if we have division and we take the reciprocal of something, we essentially want to do the opposite of division, which is multiplication. So that's why we changed from division to multiplication, all right? And what we did was we found what's called the quotient, all right? All right, I had a little message just pop up. Oh, there we go, it's gone. I couldn't switch to the pen, all right? So we found the quotient. So a fancy word for division is quotient. Quotient. Again, another thing in math that bugs me. They take something that we know, division, dividing, and they change the word. But what we did to divide rational expressions, we simply took the reciprocal Reciprocal. Kind of a tough one to spell. That's a C there. Reciprocal. We take the reciprocal of the fraction we are dividing by. So in the example above, we were dividing by 1/4 and 1/10. So what we did was we took the reciprocal, which means we flipped it over. And then we changed the division symbol to multiplication. Okay? A more common way to think about it, and it's a word that I've used already a couple times, is a more common way to think about it is we need to flip the second fraction. Then change the sign to multiplication. But then to make the process of multiplication easier, we just do what we've been doing all along. We factor, we eliminate common factors, and then we multiply what's left. Okay, so really the difference between this lesson and the previous lesson on multiplication is we just have to take the reciprocal of the second fraction or the second rational expression, and then we change it to multiplication. So we're essentially just going to do one additional step, and then we're going to do what we did last time. Okay, so in this first one, what we can look at is we can say, all right, I'm going to change this. So nothing is changing about the first fraction, but the symbol is changing to multiplication, and the second fraction is just getting flipped over. So everything moves. Okay, and then this one I'm going to treat a little differently. And when we have problems like this, it's really how you see it and what you see. And we could write everything out. We could do 3xxx and then 7y's and then over 40, and then we could do 2y's and 3x's and over a 4 there. But I like to kind of approach this like, what do you see? Well, one thing I see right away is I don't want a highlighter. What am I doing? I want a pen. There we go. I see an x to the third here and an x to the third here, so I can cancel them out. And then I don't see anything else I can cancel because the 3 and the 40 don't have a common factor. The 3 and the 4 don't have a common factor. And then the y's are all in the numerator, so I can't do any canceling there. So I just now need to multiply across. So when I multiply across, I end up with 3y to the 9th, because I add those exponents, over 160. And so I'm all done. Okay, so that's what I saw. So that's what I did. Now, if you didn't see that and you decided to go a different route, as long as you get to the same answer, that's okay. All right, let's look at another one. Wow, I didn't need that much room for that problem. Here we go. So again, same thing. What we're going to do is we're going to take the second fraction and flip it over. So I'm just going to write the first one like I did. Now, you might think, oh, I'm going to do a little factoring as I do this step. That's perfectly fine. If you want to do that, that's fine. But I'm just doing this because I'm just showing that one step where we flip it over. Okay, so all I did was flip it over. Now I'm going to factor a little bit. Sorry for moving around so much. I wanted to see what was down there. Okay, so I'm going to factor, and this first one that I'm going to do is one that a lot of people tend to miss. Anytime something has an exponent of 2 on it, it means it's something multiplied by itself. So we can rewrite this numerator as x plus 2 times x plus 2. And then since there's a 5 over there in the numerator, the other one, I'm going to write this as 5 times 2. So we have to kind of use some common sense and say, hey, I see a 5, I better have a 5 over here, right? So I don't need to do anything to that 5 necessarily. But then this numerator, I'm just going to factor out a 2 because that's the greatest common factor. And when I do, I'm going to end up with a binomial that I can cancel from up above. So I cancel one of those with that one. Remember, we can't cancel both of those up. They're only one. And then I'm going to cancel the 5s. I know you're tempted, but don't cancel the 2s. They're both in the denominator. So we want to leave those 2s alone. And so when we multiply across, we end up with just x plus 2 in the numerator and 4 in the denominator. Okay, so not too bad. So remember, it's just that one first step where we take that reciprocal of the second fraction. Now, some of you might be wondering, could I take the reciprocal of the first fraction and get the same answer? And the answer is no. What you're going to end up with is something that's a little backwards. I think it would work, and you could try this if you want. I think it would work, but you have to take the reciprocal of your answer then to get the right answer. So we should almost try that. How many? Oh, we got what? 2 more left? I suppose we could try it. Let's try it. Well, you know what? I'm afraid that might confuse some of you, so I'm not going to try it. If you want to try it on your own, you can. All right, so when I rewrite this one now, instead of just rewriting as is, I'm going to do some factoring while I rewrite it. I hope you're okay with that. So the first fraction is going to become, the first fraction is going to become 2 times 3x plus 1 over, this is one a lot of people don't see, but it's the difference of squares. Okay, so the first fraction is going to become that. Now the second one, I'm going to take the reciprocal so that x minus 1 goes up on the top. And then this one, the numerator, is just a greatest common factor one where I'm going to factor out an x. So I end up with 3x plus 1. Okay, so it's okay if you want to combine steps like this where you are factoring and taking the reciprocal at the same time. Just don't forget to do it, right? And that may be why it's a good idea to not combine steps, but I know some of you all like to take shortcuts, and that's fine. So let's go ahead and cancel something. So I can cancel that and that. I can cancel that and that. And so I end up with 2 over. Now this one I'm going to write the other direction, x times x plus 1. And that's it. I'm really tempted to try this the other way. Yeah, it would happen. So if you took the reciprocal of the first fraction instead, you would need to take the reciprocal of your answer, if you know what I'm talking about. All right. Last one. So this last one, we've got a trinomial with a greater than 1. So we're going to end up with 2 binomials. So let's go ahead and start this here. So I'm going to have a binomial over, and then the bottom is 5 times x minus 5. Okay, and this might be a little bit of a clue. I think that one of these is going to be x minus 5. And so that means this has to be 2x, and this has to be minus 1. And the thing we just have to think about is, okay, when I distribute this to that, I get negative 10x. And when I distribute this to that, I get negative 1x. Those two added together equal negative 11. So that is good. That's what we want, right? Okay, so we've taken care of the first fraction, all the factoring and everything. Now it's easy now to maybe say, oh, I forgot to, I'm all caught up in this factoring, and now I'm going to forget to take the reciprocal of that second one. But don't forget, we need to flip it over. So when we flip it over and change to multiplication, we're going to have a 10 in the numerator, but since I've got that 5 in the denominator of the other one, I'm going to write it as 5 times 2. And then the numerator, I can factor out a 2, so I have 2 times x minus 1. No, I don't. I have 2 times 2x minus 1. See? We all make mistakes. As long as we catch them, that's okay. All right, so now I'm going to eliminate common factors here. So I have a 5 I can get rid of. I have a 2x minus 1 that I can get rid of. I have an x minus 5 I can get rid of. And I have a 2 I can get rid of. Well, this is a great example. What happens when everything disappears? If you cancel everything out, some of you might be tempted to say it's 0, but remember, technically we should have something somewhere up here, maybe in this first one, where it's 1 times 5. So there's this 1 left. So the answer is 1. When everything cancels out, the answer is 1. So essentially what this is saying is that these two expressions are equal to each other. And that's pretty interesting to think about. All right, that's it as far as examples go. You know, and you've got 6 of them down here with 2 kind of crazy-ish questions. Challenge, not crazy, sorry. And focus on those. Do those because they are important. Okay? All right.